So this question is a combination circuit question. Now, just like what I said in class before, in combination circuit, what you want to do, because you have both parallel and series circuit, you want to take a step back, look at the biggest circuit, and see maybe what you should consider the major circuit and what are the smaller circuit you want to look at. So in this case, if you take a look, the biggest circuit is really a series circuit. And in this series circuit, you have a resistor here, you have a parallel circuit here, you have another resistor, and then another parallel circuit. So right now, what you probably want to do is this. Treat this series parallel circuit as some mysterious thing. Treat it as like a weird, just a really powerful series circuit for now, a resistor for now. And then treat also this other parallel circuit as also just a really powerful resistor. Yeah, just treat this as a powerful resistor. The tape kind of. All right, so just treat this as another very powerful resistor. We will solve this question right now as if it is just a series circuit, and then we'll look into it from time to time, okay? So right now, in a series circuit, a couple of things is this. Your current is the same, but the voltage is, you add up the voltage in a series circuit. So let's take a look. In this case, now this one here would be easiest to solve because in this case, if you take a look, you have the voltage, you have the resistance. Oh, I can just use Ohm's law to find out what this current is. So in this case, let's do that. So I5 here, now Ohm's law, current will be equal to voltage divided by resistance. So I have 100 volts and divided by 22.22 ohms. So in this case here, 100 divided by 22.22, that gives me about 4.5 amps. Okay? So current number 5 is now 4.5 amps. Okay? Now once you got one of the currents, because this is a series circuit, what it means is that every single current would also be 4.5. So here, the total current would be 4.5. This one here, I1, would also be 4.5. Even though they didn't ask for it, write it down. And for these two kind of really powerful resistors, they also have 4.5. We'll look at those a little bit later, okay? Now, let's take a look. So we can probably solve this one. This is probably another good one to solve because we have the voltage, we have the current, we can use Ohm's law to find the resistance. So in this case, resistance will be V over I. So you have the voltage being 240, current is 4.5. So in this case here, 240 divided by 4.5, that gives me about 53.33. Yeah, that looks right. Yeah, 53.33 ohms. That will be my total resistance. And I can also solve this one here because I also have voltage, I also have current. So resistance here would be, I kind of wrote down the formula, so I don't need to rewrite it again. So I just say 30 volts divided by 4.5 amps. So in this case here, 30 divided by 4.5, that gives me 6.66 ohms right here. So I have both RT and R1. Now, I think it's time for us to look into these kind of circuit that we earlier pretend to be, these smaller series, parallel circuit that we kind of pretend to be really powerful resistors first. So let's take a look. Now what we can do. Now if we look at this circuit here, it is a parallel circuit, and one thing about parallel circuit is this. Parallel circuit, your current, you add up the individual current together, but the voltage is the same everywhere. So in this case, they did give us one of the smaller voltage, V2, being 60 volts. So in this case, well, if this is 60 volt and this is a parallel circuit, this here would also be 60 volts. And this guy here, V3, will also be 60 volts. And the total voltage of this section here would also be 60 volts here. Okay? So that is really helpful because once we have two pieces of information here, we can easily find the third thing. So third thing here, for the second resistor, I2, we have the voltage, we have the resistance. So we just need to, we have the voltage, we have the resistance, so we just need to V divided by R to give us the current. So let's do this one here. I2 is the same thing as V divided by R. So V is 60, R is 24. That should give us about 2.5 amps. Yeah, that's 2.5 amps here. And down here, we also have voltage, we also have resistance, so we can do the same math. So we have 60 volts divided by 40 amps. So in this case, I have 1.5 amps here. Okay, I have 1.5 amps here. So now I have I2, I have I4. Now, for this little middle one, resistor, we only have the voltage so far, but one thing here is this. Because it is a parallel circuit means the smaller current here, add the smaller current here, plus a smaller current here, would give me 4.5 amperes. So I can definitely, since I have two of those current already, I can figure out what this I3 would be. So I'm just going to write down here. So I total for this part is 4.5 amp, and I total is the same thing as I2 plus I3 plus I4. I total is 4.5. I2, we just calculated 2.5 amps. I3, we don't know. I4 is 1.5 amps. So in this case, 2.5 plus 1.5, that will give you 4 amps. So basically 4 amps plus whatever current this is gives you 4.5. Well, then in this case, I3 must be half or 0.5 amps. That will give you that will add up to give you 4.5. So here now I3, we now know is 0.5 amps. So we have two numbers, voltage, we have current. We can figure out what the resistance is. And I'm just taking this down. Then in this case, this resistance will just be 60 divided by 0.5. 60 divided by 0.5. That will give you 120 ohms right here. So we also have I3. Okay. So we're pretty much done over here. We now want to tackle the thing on top. We have the current 4.5 amps. Now looking at this, we don't have any information about the voltage, but the good thing about it is that in a series circuit, voltage, total voltage equals 30 plus 60 plus 100 and plus whatever this is. So we can solve what the voltage for these two together, and then we can use it individually, okay? So for this part here, the voltage here, for this, let's just say the total voltage here, let's just use a small t, okay? So in this case, this small t here would be the big total voltage of the series circuit would be voltage 1 here, because it's a series circuit. We have 60 volts for this whole thing, and let's just say 60 volts, plus V5, which is 100 volts, plus V small total, okay? V total is 240 volts. V1 is 30 plus 60 plus this one is 100 plus V total. So in this case, you add up these three numbers together, you get 190 volts plus VT. You have 240 here. So to find this voltage here, basically you get 240 minus 19, 190, sorry. That will give me 50 volts. Okay? So now we found out that this whole parallel circuit here is 50 volts. And we're going to remove this here. So we know that this is 50 volts. This parallel circuit is 50 volts. So because it's parallel, it means this is also 50 volts. This is also 50 volts. So I6 is also 50 volts. With the voltage and the resistance, I can calculate the current. Okay, so this is 7, right? Yeah, this is 7. So let's go over there, and I'll use a different color. Okay, I'll use a different color. So I7 would just be voltage divided by resistance. So the voltage is 50, resistance is 25 ohms. So the current will just be 2 amp here. So here I7 will be 2 ampere. Wait, this is supposed to be V. Okay. So in this case, now I have 2 amps here. I have the current for 7. I have the total current of 0.45. And since this part is a parallel circuit, the current for this one, current I6 plus I7 will give you 4.5. Okay? I6 plus I7 gives you 4.5. So in this case, this is 2, this is 4.5, so I6 is really just 4.5 minus 2. That gives me 2.5 ampere here. So that's I6. I can solve for resistance. Last a little bit. 50 volts divided by 2.5 amps. That should give me 20 ohms. 20 ohms. Okay. So yeah, I think that's all the things we need to do. So as I said before, combination circuit, you kind of do need to, from time to time, step back, look at the big picture, determine to treat it like a series or a parallel. Zoom, take care of whatever information you can find. So earlier I found this, and I found the information here and there. And then I zoom in, I focus on this one. And at times I zoom back out so that I can figure out what is the voltage and then proceed onward to solve the other stuff. Okay, so that's kind of what you need to do for combination circuit. Do more practice, you will get better and more comfortable at it. Thank you.